You know that phone in your pocket or the car sitting in your driveway? They weren't just made in one place. Nope, they're a mosaic, built from pieces that have crisscrossed the entire planet. And trying to coordinate that, well, that global dance is one of the biggest, most complicated scheduling puzzles we've ever faced.
So, how in the world does a company, whether it's making a car or a simple coffee machine, get all of its factories, all of its machines, all of these moving parts to sync up? The main goal is simple: get the product out the door as fast as humanly possible. But the scale of that challenge, it's just mind-boggling.
So here's the plan. First, we're going to look at this puzzle in a perfect world. Then we'll throw in some real-world chaos to make it interesting. The solution, believe it or not, comes from bees. We'll see how a super bee algorithm was created, watch it go head-to-head with its rivals, and then we'll break down why any of this actually matters to you and me.
All right, let's dive right into the puzzle itself, because to really get why the solution is so cool, you first have to appreciate just how tough the problem is for the people running these factories every single day. You can boil it all down to two massive decisions for every single task. First, which factory, anywhere in the world, is going to get this job? And second, once it's there, what's the exact order of machines it has to go through? Get either one of those wrong, and you've got a domino effect of delays and costs spiraling out of control.
Now, this whole puzzle has a super technical name: distributed permutation flowshop scheduling. Yeah, I know, it's a mouthful, but let's break it down. Distributed just means it's spread out over lots of factories. Flowshop means the jobs all follow the same path through the machines. And the goal? It's simple. Line everything up to finish the whole batch of jobs in the absolute shortest amount of time possible. Experts call that the make span.
Okay, so that's the puzzle on paper, nice and clean. But here's the thing, reality is anything but clean. A perfect plan almost never survives the real world because reality loves to throw in curveballs that mess everything up.
There are two big wrenches in the gears here. First, something called the no-wait constraint. For some things, like making steel or processing food, once a job starts, it cannot stop. It has to flow like a river from one machine to the next, with absolutely zero downtime in between. Then you've got the simple fact that machines break. They get worn out, they need to be serviced, and you just can't skip that maintenance.
And we're not talking about a small hiccup. As the researchers put it, these maintenance breaks disrupt tight schedules. That's the polite, scientific way of saying they can completely blow up your perfect plan, causing everything to take way, way longer.
And how much longer are we talking? Well, the research gives a pretty shocking example. A perfectly planned schedule might finish a batch of jobs in, say, 25 hours. But once you factor in the time machines have to be down for maintenance, that same job now takes 39 hours. That is a 56% increase in time. That's a huge hit to your efficiency.
So what we have is this insanely complex puzzle, and it's made even harder by the messiness of the real world. So how do you solve something like that? Well, the answer isn't just about more computing power. Turns out it's about looking to nature.
See, here's the thing. You can't just try every single possible schedule. The number of combinations isn't just big, it's practically infinite. It would take the fastest computers we have today thousands of years to check them all. It is literally impossible. You need a smarter way. You need a shortcut.
And that shortcut is called a meta-heuristic algorithm. It's a fancy name, but the idea is actually pretty simple. It's a problem-solving technique that's inspired by how nature does trial and error, like evolution, or the way a swarm of bees finds the best patches of flowers. It's not about finding the one single perfect answer, but it's amazing at finding a really, really good answer, super fast. And the behavior of bees is a fantastic model for this. It's called the artificial bee colony algorithm. Think of it like a team of digital bees. First, you have the scout bees. They just fly out and explore totally new, random possibilities. Then you have the employed bees. They find a good spot and they work it, trying to make it even better. And finally, you've got the onlooker bees. They hang back, watch what everyone else is doing, and then they all rush over to help the bee that's found the best solution so far.
Now, that standard bee algorithm is already pretty clever. But the researchers in this study thought, we can do better. So they set out to build a new, improved, hybrid super bee.
And that brings us to the star of our show, the Hybrid Artificial Bee Colony Algorithm, HABC for short. It takes that core idea of a bee colony and just bolts on some serious upgrades.
So what makes this HABC algorithm so special? Well, three things. First, it's smart. It doesn't look everywhere at once. it zeroes in on the critical factory, a fancy way of saying it finds the one single factory that's causing the biggest traffic jam and focuses its energy there. Second, it digs deep. It doesn't just scratch the surface of a good solution, it uses a powerful search to really explore that area for an even better one. And finally, it's efficient. It uses these clever little moves called shift and swap to test out tiny changes to the schedule incredibly fast.
So the HABC sounds great on paper, but does it actually work? Well, there's only one way to find out. The researchers set up the ultimate test, a no-holds-barred algorithm showdown.
They took their new creation and put it up against a bunch of other top-tier scheduling algorithms. And the results? Well, they kind of speak for themselves. On this chart, remember, lower is better. And as you can see, HABC didn't just win, it left everyone else in the dust. If you want to put a number on it, HBAC got a score of just 2.21. Its closest competitor, way up at 6.4. In this world, that is not just a victory, that is a complete and total knockout.
Okay. So an algorithm inspired by bees is really good at solving a computer problem. That's a cool headline for sure, but why should we care? Because solving this abstract puzzle actually has very real effects that reach all the way from the factory to your front door.
Just think it through. A smarter scheduling system means a more efficient manufacturing system. That means our global supply chains are stronger and can handle shocks better. It means less wasted time, less wasted energy, and less wasted material. And all of that efficiency, well, that can actually lead to more stable prices, maybe even lower costs for the things we all use every day.
So in the end, the key to a major 21st century manufacturing problem wasn't something cooked up in a sterile lab. It came from watching the beautifully simple collective intelligence of a beehive. And it just makes you wonder, if bees can help us build better factories, what other secrets does nature have, just waiting for us to discover, that could help us solve our next big problem?